Well, hello, everyone. My name is Brendan Finch. I taught middle and high school science in Los Angeles for 7 years, and I left the classroom to start rocketlit.com. So it's a leveled adaptive science reading website. And in the process of working with schools and districts through that, we started working on Inner Orbit, and that is what we're here to talk about today. And Inner Orbit focuses on assessments for the NGSS. So much like the STEELS standards that are coming up for y'all, we build three-dimensional assessments, and I'll talk about what those look like. But it was a need that was pretty clearly defined by all of the district administrators and students and teachers that we spoke with. I wrote a lot of the assessments on the site to begin with, and now I spend most of my time speaking with thought leaders and working with our team to ensure that we are doing our best to create new resources to support admin, students, and teachers. So some of that are webinars like this. I also just want to state for the record that I believe that burritos are definitively better than tacos in every way. Anyways, so as we move on, I want to introduce Inner Orbit really quickly to explain what this is, so you understand the premise for what we're doing today. So Inner Orbit is pretty simple. So the first thing that we do are we build these phenomena. These are sort of chunks where students can take what they've learned in class and see these new things, these new phenomena. So things that happen in the natural world that can be explained with science knowledge. So we'll, give students something, around the Mars rover and forces in motion, and ask them to apply their understandings from class and from what they learned about forces in motion in their, like middle or high school or elementary school physical science class. And with those, we write questions. Our questions are written to very, very, very specific parts of the standards. So we'll say some are tied to an SEP, some are tied to a DCI only, some are tied to a cross-cutting concept in a DCI, and others are three-dimensional, really rigorous, to see if students can take what they're learning and apply that to make sense of something new. And those questions are written in a granular way so that we can give you really, really detailed reports. So what this screenshot is a shot of one of our reports called our dimensions report, and we're looking at an SEP of developing using models. And this SEP, the science and engineering practice, has lots of different parts. We're looking at a breakdown of what students should be doing at the 3-5 grade level. That's what's up in the top with a green box around it. And then things that students should do at a 6-8 grade level. And all of these are pieces that we've pulled from the appendices of the NGSS. So smaller parts of these science and engineering practices. So for example, in the 3-5 grade level in this report, students did a really good job answering questions where they had to use a model to test cause and effect relationships or interactions concerning the functioning of a natural or designed system. That's great. And students struggled at the 6-8 level. So when we had data around 6-8 and we asked them this question, they struggled to develop a model to describe unobservable mechanisms. So every time we asked them questions around that, they really struggled. And so what we're looking to do with this report is enable districts and teachers to sit down and look at data and be able to make data-informed decisions about what their students need. That way, we're not just saying, we're going to just go through each SCP throughout the course of our PD, or we're going to dive into one SCP and that's going to be our focus. You can use data from assessments to drive those decisions. We also do a lot of professional learning. So if you're interested in diving into some professional learning around the SCPs, the DCIs, the cross-cutting concepts, then Inner Orbit is a great place. We'll go to you physically, which is fun, or you can find a time on our calendar and we'll do virtual professional learning sessions as well. If you're interested in learning more, and if you're watching this as a recording, it is in the description of the video for you to start a pilot. And if you'd like to explore Inner Orbit and take a look at what we do, that would be great. We're here to talk about using phenomena throughout a unit to support sense making. So today, we're going to explore some instructional strategies and assessment strategies to help scaffold students up to making sense of a phenomena throughout a unit. So our big goal here is that students can take what they're learning and apply that, at the end of a unit. But there are ways that we can insert phenomena throughout instruction to support that process. It shouldn't be a surprise. Now here's a new phenomena. We're going to be here for about 45 minutes. We may get to 50 minutes, but I think that'll be enough. All right, so we're going to talk first about phenomena as the journey and the destination. So we'll look at phenomena and some state assessments. I realize that the STEELS assessment does not yet have some phenomena that are out, so we'll look at some other states. We'll look at a phenomena roadmap. This is a creation of our organization to help kind of like put into imagery how you can use phenomena throughout the course of a unit, not just as your instructional phenomena and your assessment phenomena. And then we have some experimental things that we've been working with in Orbit. These are purely experimental, and they're things that we're developing to give more informal practice for sense making, which is kind of the purpose of using phenomena throughout a unit. We'll look at some of those phenomena and look at some strategies for using phenomena throughout a unit in addition. And the big goal, again, is just helping students to access and transfer knowledge to phenomena. So we just want to give them more opportunities to do that. I think, big picture, we'll look at what the state tests look like, and it'll be obvious to you what needs to happen in order for students to be successful with that. So I'm excited to do this. All right, let's go. All right, so first piece of our session today, we're going to look at phenomena as the journey and the destination. And first, we're going to look at the destinations. So we're going to take a look at phenomena from different state tests and consider what we're asking students to do with these phenomena. So the first one we're going to look at is from the Colorado state test. So in this state test, what they do is they give students some imagery. They say, here is a lake in late August, and here is it in early September, and here it is again in late September, and here are some details on the ecosystem that we see within that lake in late August and late September. And so again, we're seeing a changing ecosystem right here. And they'll ask the question, they say, based on the information, explain how resource availability affects populations in the pond between late August and late September. Your response should include an explanation of how during each of those two time periods, 1, the plant population is affected by resource availability, and 2, the fish population is affected by resource availability. So we're looking at these two different populations and how, like the changing ecosystem impacts resource availability. So real quick, I'd like you to consider, can students memorize the answer to these questions? And I also want you to consider, how are students making sense of this phenomenon? If you're watching this as a recording, you can write those responses as a comment to the video. We would love to read them, and I will respond to what you write. We'll move on to the next couple of questions and set the basis for what does a summative assessment look like around these three-dimensional standards. So for the second slide that we're going to go into, we can look at the California state test now. So the California state test will ask students, whereas the other one was a free response question, this is a multiple choice question where students choose a couple different answers. And they say, there are these fish that live in this shady pond with a dark bottom. There's a new predator that was added to the pond, row. And one of its small food sources is the small fish, obviously. And so what we're looking at is the percentage of each fish in this population before and after this new predator was added. So there is the color of fish, there's before the new predator and after the new predator. And you can see pretty plainly that for the light-colored fish, after the new predator, not a large share of the population, a diminished share of the population. And for the dark-colored fish, after the new predator was added, there's more. They have a larger proportion of the population. And so they ask students, based on the data in this table, select the best phrase from the menu to complete each sentence. And so now students need to take, all this data from the table. They need to understand how, there's some mechanisms in this ecosystem whereby that new predator is predating on the light-colored fish more than the dark-colored fish. And students should understand that probably the dark-colored fish have a better chance of surviving. We can see that after the new predator is added, there's more of them in the ecosystem, and the light-colored fish have a lower chance of surviving. And it's probably because maybe they can seek them better, because the only variable we're given is that there's light and dark things in the ecosystem, and these fish are light or dark. So most likely it's a color thing. That's what students would need to answer. And so same question here. I just want you to think about, can students memorize this answer? And the answer is definitely no. So we're going to give them different phenomena in our instruction, and then they need to take their understanding of the relationship between changing ecosystems and predators and apply that to this. Just like in that Colorado example, they need to take their understanding of resource availability in any ecosystem and apply that to this novel phenomena of that pond with the algal bloom that we saw. And then we can move on to the New York Science Test, which you may not be surprised to see looks very, very similar. And so we can see that we have this situation, 400 million years ago, planet Earth was much different than it is today. Seas covered much of New York State. And we know this because there are fossils that have been found and have been exposed over time through weathering and erosion. And so the question that we ask, and they give some maps and data tables, and also these images of these two different fossil parks, so Penn-Dixie and Thatcher Park. And then the question is asked, they say, the continent of North America is inferred to have moved from its location 360 million years ago to its present day location. Provide one piece of evidence that supports this past plate motion. So what students are doing is they're pulling evidence from several different sources of information, and they're using that evidence to explain how that shows that the plates have moved over time. And so it's not just that the plates have moved, but it's finding this evidence and then using that evidence to explain that the plates have moved. Pretty interesting. So same thing as before. This isn't something that students can memorize. They need to be able to pull evidence from the images, from the data tables, from the sets, from the models that they're given. And they can't just memorize the answers to these things. And so what I'm going to do right now is I want to dig into one of these performance expectations, and I want to recap, what students need to do. And so we're going to use the example from the New York State test. And that performance expectation, or that is assessing, is MS-ESS 2-3. So this asks students to analyze and interpret data on the distribution of fossils and rocks, continental shapes, and seafloor structures to provide evidence of the past plate motions. And within that, they need to analyze and interpret data. So really important, New York specifies that it needs to be more than one data set that you need to look at to do that. And you can see that in the prompt that I showed you, that there are several different data sets where students have to look at those and pull evidence from multiple things. Even the text is a set of data. And they need to understand that tectonic processes, generate a new ocean floor, and that maps and patterns and fossils and rocks show us that plates have moved over time. And the cross-cutting concept is that we need to find patterns in the rates of change and other relationships to give us information about natural systems. So obviously, there are patterns in the fact that there were things that were probably under the ocean at some point and are not anymore. And so we can use those patterns to justify, and we can see that with different plate motions, different phenomena. We can use those patterns to justify what happened here in these fossil parks in New York State. Okay, so let's say we're going to walk students through this standard, and throughout a unit, I want to use different phenomena. So I want to give you a roadmap of different phenomena that you could use throughout the course of that unit to give students lots of different examples of a phenomena. So instead of just telling them about plate tectonics, we're going to show them through many different specific examples so that when they get to an assessment, they're used to seeing many different specific examples, and they can take their understanding and very, very easily apply it to make sense of that new thing on the state test. Okay, so example number one, how is there a forest in icy Antarctica? And so for this standard, students are looking at the fact that, Antarctica, which is pretty cold right now, could not support a forest. We have fossils that show that there was a robust forest in that ecosystem earlier. So we can talk about that in the beginning of the unit. It can be a whole class discussion that we can talk about. And then in the middle of the unit, maybe we're going to talk about why are rocks on opposite sides of the ocean so similar? So I'm going to give another very specific example, showing that there's an obvious, similarity between the rock layers in South America and in Africa. So super, super similar example. And that we can use that to justify the fact that there is a pattern in that relationship and that those things were probably in a different place and maybe connected before, probably connected. And then at the end of the unit, we can say, how can a new island teach us about the ancient past? And so this is, looking at any, we can use any island that we want, or Iceland, which is one of our favorite ones, because that's something that is constantly growing throughout the course of the year and into the future, which is super fun. And ask them to say, how can we use the patterns that we see here in this island, in the formation of different islands, like in an archipelago or in Iceland, and ask them to explain how evidence of plate tectonics shows, what is happening with this island formation. And so this is a roadmap of different ways you could use different phenomena through the course of a unit. So let's go into the details of exactly how you would use those phenomena within your classroom. So that first phenomena looked at icy Antarctica and a forest in icy Antarctica. And we give students different data sets. We show them these different bands of information. And so scientists find these fossils. They find these fossils of pine trees, moss, and ferns. And specifically the plant fossil that we look at here is Glossopteris. So this is something pretty common when we talk about plate tectonics, because there's great evidence to show that we find this in 5 different continents. There's no way that that plant somehow like transported itself. These aren't coconuts. All right. So we give students this information. And at the beginning of the unit, if we're starting students off with making sense of a phenomena, we want to do an exploration. And so what that looks like is a class walkthrough and discussion. So I'm going to project this phenomenon up on the board, and we're going to talk about it. So I am going to walk you through, maybe some of the DCI concepts. So you can see that, this Glossopteris is found in 5 different continents. That probably means that, they work together at some point, and we can use that as a way to show that, okay, so if they were together at some point, then, they are in a different place now, and that change, is evidence that there are movements of Earth's plates. We can also very explicitly cite the cross-cutting concept of patterns. We can use the SCP of analyze and interpreting data. We can give these different examples of these different maps, and I, as the teacher, can like model the process of sense making and obviously ask students. But this is a highly scaffolded beginning of the unit example of what you can use for phenomena at the very, very beginning of a unit. Now, let's say we do that, we do more direct instruction, students are getting more and more familiar, and we're ready to kind of like turn up the heat. So we give them a different phenomena. This is that mid-unit phenomena that we said earlier, where we looked at why are rocks on opposite sides of the ocean so similar. So we're looking at South America and Africa here, and looking at the similarities between rock layers between those two things. And there's also patterns in sea floor that we look at. So we have a map of that. We have, looking what a divergent plate boundary looks like and a model of that. And again, we're giving students a lot of the answers here, but what they need to do is pull data and evidence from this information to explain why or how it's happening. And that is the difference between direct instruction and sense making, where now we're saying, okay, like here's a bunch of information, now make sense of it for me and pull it together. So in the middle of the unit, we want to consider maybe giving a printed and scaffolded group phenomena exploration. So we want to give students an opportunity to sit in groups. And maybe as a teacher, I might walk students through each of these different models. Maybe I'll have them annotate that, like I'll project it up on the board and say, all right, like, what do you notice about this one? Yep, things are connected. Or maybe I'll have them do that in groups. But noticings and wonderings are a great way to get things flowing. And you could do that. Model it as a teacher for the first one, and then ask students, okay, so in the second figure right there, which shows, the breakup of this Pangea continent into multiple separate continents, like what patterns do you see here? And like how would rocks on opposite sides of the ocean be so similar? Looking at that example. Now let's look at figure 4, which is, the sea floor age. What patterns do you see around South America and Africa that show that maybe those two things, were together at some point? So super interesting. Okay, so the whole class walkthrough is something that you can do with a lot of scaffolding of DCI concepts. So I may explain some of these things very explicitly to students, or not. If I feel like students got it, then I don't have to do that. But the big picture here is that students aren't just answering noticings and wonderings, they're answering rigorous questions. We're going to ask them 2-dimensional questions, 3-dimensional questions, questions that ask them to explain how or why this thing is happening. How or why are the simulators of the rocks evidence of plate tectonics? So we want them to explain that thing. You can still support them, you can still walk around, but we recommend on inner orbit, you can print out phenomena and print out questions. And then we have teachers that will give those to different groups and say, all right, maybe I'm going to do some scaffolding on the board, you can write that stuff down. And then with your group, you're going to look at the phenomena and answer questions about that phenomena. All right, great. So now we've reached the end of our unit. Hooray. We're ready to start moving forward with additional rigorous stuff. Now, at the end of the unit, what we want to focus on, aside from how can a new island teach us about the ancient past, is an individual assessment. So the reality is your students need to be able to do this on their own at some point. And I'm going to be honest, in the very beginning, it is brutal. Students struggle, and it's really, really tough. And so in the beginning, you're going to want to just tell students, hey, like this is going to be hard. And it's going to be a struggle. And that is okay, because you should expect to improve over time. And that is what we want to see, is that improvement over time. So that individual assessment should be probably shortened online, because that's probably what the STEELS assessment is going to look like. We recommend that questions scaffold up. So on in orbit, we write questions that focus on just the DCI, what students know, and then incorporate either the cross-cutting concept or the SCP to 2-dimensional questions. Then we'll ask 3-dimensional questions later on to kind of scaffold that up. So you can do that, or you can write those questions on your own, whatever, but we recommend that you scaffold that up. So validating the students know stuff, they can make connections between those two things, and then really rigorous for response questions at the end, because we want you to explain your thinking. That's the big idea. So teachers can still provide scaffolding. So if you need this, especially at the beginning of the school year, or if your sixth graders are just entering into these, like, the world of making sense of phenomena. But then by the end of the school year, the end of a unit, towards, as you feel them becoming more independent and comfortable, you got to remove the scaffolds and you got to make them do it on their own. So let's just say you say, hey, I don't know if my kiddos can use this middle school earth science content. Well, then you can walk back to a prior grade level band. So take that middle school ESS standard and go back to the fourth grade standard. So 4 ESS 1.1. And this standard says identify evidence from patterns in rock formations and fossils and rock layers to support an explanation for changes in the landscape over time. So this is just looking at the fact that landscapes change. We're not looking at plate tectonics. There's no mechanistic approach here. It's just that they have changed. Why? IDK, but they've changed. And so for this, we can go back and say, all right, so how did these dinosaurs walk up a mountain? And we're looking at these dinosaurs that are discovered up a mountain where there's no way these dinosaurs could have walked up this like steep rock face 70 million years ago. It's a long time ago. So that means that environment has changed over time. Or we can look at these fish. And in France, we found these fish fossils. It's not near the ocean. And those fossils and rock layers provide evidence that at some time this area was under the ocean. And then later on, we could look at, why were flowers found in the coldest place on Earth? And so in Antarctica, we find all these fossilized flowers and different rock layers. And so that environment has changed over time. And we don't need to understand the mechanism of change, but just the fact that they have changed and that is evidence that they've changed. Okay, so just to sum up, some main takeaways from this are that practice makes perfect. You should use phenomena throughout a unit to prep for state tests. Using different phenomena also gives more opportunities for your kiddos to model and practice transferring knowledge and sense making, and you as a teacher to model that stuff. And you can always lower the stakes with the prior grade. So you can give students a prior grade level band phenomena to allow them to make sense of things with a lower demand from the DCI perspective. And that is the summary of that. And now I'm going to go through some experimental content that we've been working on within Orbit to give students other opportunities to do this. So these are ways that you could structure like a phenomena drill, or we call these like warm-ups. And so at the beginning of a lesson, as a teacher, of course, you should read through the standard to understand. The phenomena that we're looking at here is, why do hurricanes appear in these same places? That's weird. And we'll offer them a simple image and a simple question. We'll say, this map shows 150 years of hurricanes that started off the coast of Africa. What patterns do you see in where hurricanes occur? And so we want students to use the cross-cutting concept of patterns to explain, how that there are patterns, to identify those patterns. So all we're looking to do is identify evidence through the lens of patterns. And then we can say, like, how might the rotation of Earth impact where hurricanes occur? And so now we can sort of weave in the Coriolis effect, get into that DCI. So, like the mechanism or one of the mechanisms that guide the way that these hurricanes form. And then maybe we can give them another, like maybe on the third day that we're giving these to now. So we can say, why are hurricanes and monsoons found near the equator in the middle of the map? And why is there a space in the middle where there aren't any large storms? And these don't have to be things that we have students answer, but we can just have them notice and wonder and try to make sense of all of this data. Cool. We're also building out scaffolds for, this is experimental content where we're building out scaffolds for the SCP of developing using models. And we're doing that through the lens of this 5th grade standard, 5 ESS 2.1, where students have to develop a model using an example to describe ways that the geosphere, biosphere, hydrosphere, and or atmosphere interact. And so we'll give students this phenomena. So this is car cruising down the street. And then all of a sudden, this enormous boulder falls down in a landslide onto the street and almost goes squishy with that car. And so what we can do with this is ask students to observe, make observations in those images. What spheres do you see? And then maybe we can have them label those spheres in the image. What's cool about things like this is students are going to give different answers. So you're not going to get the same thing over and over and over again. But students can look at this one specific phenomenon and start to make sense of it and scaffold up that big model they have to do, maybe at the end of a unit. Maybe they can drag and drop arrows or draw their own arrows to show how those spheres are interacting. And then at the end, we want them to use a model to explain how those arrows show the interactions between spheres. And so that right there is the final, the goal of the performance expectation. And this is something maybe you could do before an assessment or after an assessment. If students struggle with that model of interacting spheres, you could use this as a way for students to share out all the different ways they interact. And what's cool is, students are going to see different things in this data. And so you're going to see lots of different ways that those spheres are interacting so that, ideally, they will be able to do better on an assessment or additional tasks that require them to use models to show how things or why things are interacting. Cool. So what's one way you can start using phenomena in your next unit? And I gave you a couple of ideas, but as you're watching this video, think about, is it going to be a do now? Is it going to be kind of like a scaffolded group practice? Or is it going to be an individual online assessment? Those are 3 different ways that you can incorporate them just from there. And now I want to go into some additional strategies for using phenomena 3D unit. And I want to kind of like very deeply explain each of these ideas for y'all. So one is in a whole group discussion, this is going to be super informal. And you're just going to use verbal questioning. So at the beginning of your unit, that's kind of like what we referenced in the very, very intro to this phenomena 3D unit. We project the phenomena up on the board. And we have 1 to 3 verbal discussion questions, like what pattern do you see and where these hurricanes occur? The teacher's going to lead the discussion. They're going to ask probing questions. Why do you think that? What evidence supports your perspective? Some of the pros on this is it's super scaffolded and teacher directed, obviously provides space for students to access prior knowledge in a low stakes context, and gives the teacher an opportunity to model sense making to students. Some considerations when you're doing this is that misconceptions may come to the surface, and you just need to be comfortable with that. That's the reality. And actually, this is data gathering. You can use that to then reference those things later on. And we're not trying to hold students accountable in a meaningful way. And that can be a bug or a feature of this, depending on your perspective. But the idea here is that we're going to have a talk. Now, the second thing is this printed group work. And so this is lower stakes, but it's more formal questioning. So what we want to do is build a phenomena, and you could use an orbit for this, or you could take it from anywhere with maybe 5 assessment questions. Students have an individual paper and the phenomena that they go through, and students sit in groups. And so this is something that's great for working up to an independent analysis. So now we're sort of gradual releasing control for students. It provides some flexibility for students to write on the paper and not deal with technology. It's nice to just simplify things and say, don't worry about your Wi-Fi connection or your battery. Let's just, just annotate on the paper. What do you write down what you see in this graph? Summarize this sentence, cross out these answers. Students also have the chance to explain the reasoning to their classmates so that the conversations can be really rich, and they can go through the process of sense making together, which really, really helps later on when they need to do this independently. So considerations here is that this is not something you want to do at the very beginning of the unit unless your students are really comfortable, because it's probably going to be real quiet in there if they're not doing this at the middle or end of a unit. And then at the end, you should have a whole group debrief, because things may come up that you want to address, and it's important to be able to do that. Your classroom should not look like this. It should be a classroom where there's active collaboration, participation, and conversation happening, and that is what we want. All right, now this next idea is something that we pulled from one of our partners in Maryland who are building these transfer stations. And so what they did is they took 3 to 5 on an orbit, we call these summative assessments, but imagine just 3 to 5 different phenomena with questions for the same standard and different phenomena. And we want students to explore those phenomena in groups. And so what they did is they put phenomenon number 1, icy Antarctica, the flowers, the fish fossils in France, at different tables in packets, and students would rotate between tables. And they would see the same idea, the idea that plate tectonics is a mechanism that changed environments, and we could see that in evidence from rock layers or fossils, or there's lots of different sources of that evidence. And students then see that same idea again and again, but through different scenarios. And this can help them make deep connections and also spark some curiosity. And we can use scaffolded questions, so we can slowly get students up. So think of questions that build over time, like what is this? What's the evidence here? How does that evidence do this? Now use the answers to the first 2 questions to explain why that evidence shows plate tectonics. And some considerations are that in groups, students can support each other with pre-assigned roles. So if there's a writer and a recorder and a timer, and each of them can be have a specific role, and they can all work together. And again, this is also something that we should do at the end of a unit and debrief afterwards. So talk about what happened in those transfer stations. And what we really want to do is get students to pull the thread of, I see a pattern in the fact that when you teach me one thing, I'm going to see it in like everything else, because that's what science is. It's not just learn this one thing, but there are ways that we can decode the world and make sense of it. That's what we want to do with all of this, so that we can all work together. I don't know if that's a dog or a cat, but I love it. All right, so finally, the last strategy I want to go over are online summative assessments. These can be single phenomena, or they can be unit assessments that have multiple different phenomena. But the big idea here is that we want to choose two-dimensional, three-dimensional questions for the same standard for a formal assessment. This is going to be like, now show me what you know. So some pros is that students get practice with computer-based testing. You can use InOrbit for this, so there are other platforms that have phenomena and questions. And you can also get some deep data gathered. So InOrbit does this really, really deeply. But any way that you can get students to do things independently and individually, you need to get data so that you and your colleagues can sit down, whether teachers or teacher leaders, and figure out where students need support. And now we give you an opportunity to independently make sense of phenomena, which is really important. Some considerations here are that it's less scaffolded, and some students may genuinely struggle. And I mean, like, they may just be sitting on the struggle bus the entire time you're doing this. And that's okay. We recommend doing this at the end of a unit or learning, so that we can give students lots of scaffolding and then let them do it on their own. And you may not want to debrief for test security lessons or test security reasons. If you tell all of the students in period 1 the answer, then students in period 2 might be like, nice, like everyone in period 1 told me the answer, which could be a bummer. Cool. And that's it. Thank you all so much for being here. We did Joe. We explored some strategies to look at this. We spent between 40 and 60 minutes, as promised, going through this. And we're very, very grateful for your time in taking a look at all this information and in spending time to grow your practice. So if you have questions, write them as comments on this video or drop them in the chat right now. But I hope you all have a beautiful rest of your day, and I'm very grateful for you taking the time to be here. Take care, everyone.